Okay, we'll do a little help with the homework. The main idea now is that we realize that side and side angle side congruence are two shortcuts that we can look for. Okay, so on these problems up here, it says determine whether the following triangles can be proven congruent using the given information. If congruency can be proven, write a congruence statement and identify the postulate used to prove congruency. So remember, the only two that we know right now are side angle side and side side side. Or the answer could be none or not possible. So on the first one, when I look at this problem, I should see that these two sides are marked congruent. And I know that that's a right angle. I do know that this other side's a right angle, so I know that those two angles are congruent. And then this side BC, you're going to have to look out for this. This is everywhere. That this side is shared. So BC in the triangle on the left is the same length as BC on the triangle on the right. So they share that. So it's also congruent. So this one, I would say that this looks like side angle side to me. I have side angle side in this triangle, and I have side angle side in that triangle. So you're going to write a statement like triangle ABC is congruent to triangle SBC because of side angle side congruence. All right? It's really that easy. This one, they share this side. So anytime there's a shared side, you can see shared sides all over the place here. Some of them don't have shared sides. But I'm looking at the markings right here, and I notice that this one's marked with SSS, and so is this one. So I'm going to say it again. Triangle. I'll start here. I'll go DAB is congruent to triangle. Now I got to name this one in the same order, and technically that would be BCD because of side, side, side. All right, that's how you're going to answer these. Okay, let's do this one. This one, the only thing we can add legally right here without just making stuff up is I can always add vertical. All right, so some of you are probably thinking I've got two sides in an angle, two sides in an angle. So this one, though, if you look closely, this is not side angle side. This is a big mistake for a lot of people because in order for it to be side angle side, it would have to be the angle in between the two sides. And this one, technically, those triangles, and I will have to show you this in class, those triangles could be constructed with these three things happening, yet the other parts of the triangles not be congruent. So this one, we would say not possible. That is not either one of these. So you just got to say not possible. All right. You can do that section. So let's look here to the next section. So these set of directions are a little bit different. It says state one additional fact. So when we do these problems, we're trying to train your brain to get ready to do proofs, from an open format from the beginning. So state one additional fact that would make triangles congruent by side, 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 or side angle side, and name the postulate. Write your answer as a conditional statement, if then. So on these, when it says state one additional fact, that's giving you the green light. You get to add anything you want to this, one additional fact, and you don't have to have a reason. That's what that's meaning. You do not have to have a reason. We're just going to try to complete side, 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 or side angle side. So one of the things I see right here is if I had BC congruent to DF, I'm going to mark it. So I'm going to write this. I'm going to say if BC is congruent to DF, then triangle ABC would be congruent to triangle CDF by side angle side. There we go. Okay, and so you're going to write the full sentence, if then, all right, because we're saying we can add anything, that's the if. This one could go both ways. I could make side, side, side work. And some of you may see that first, and some of you might want to do side angle side. But some of you could add angle A congruent to angle E. Or on the if, you could say that if BC is congruent to DF, then the triangles are congruent by side, side, side. All right. So like over here, this one only has one thing given, but this is not an additional fact. That fact is happening, but we just have to recognize that. All right. So I may want to answer this one this way. I'll say, well, if I knew that CD, so if CD is congruent to BA, then triangle BCD is congruent to triangle DAB because of side, side, side. All right, again, some of you would have saw it differently, and y'all would have, your additional fact would have made it side, angle, side. So that's how you do this section. You need to complete it with sentences. Okay, on this page, it says, basically, we're getting you closer and closer to doing a proof from the beginning. So it says, in other words, what theorem would you end your proof with? Mark any parts that are equal in measure. So this one has a little bit more with some given information. So you have to pay attention to this given information, and we're going to have to mark it. Because when we do proofs, that's always what we're starting with. So, a simple one right here is ABCD is a square. Well, what do we know about squares? Well, I know that all sides are congruent in a square, so I would add those markings. And then I also know that they share this side. That's kind of a given. So I would say I could see immediately right here without doing all the steps or writing anything out. It just says, what theorem would you end your proof with? That means you're going to end it with either side, angle, side, or side, side, side. So we've learned these two work, and we're still on the lookout for those. And so this one right here would be side, side, side. We don't have to do anything else. It doesn't ask us to. Okay, let's read the given on this one. So this is all about reading the given. So the given AB is congruent to CB. Okay, it's not marked, but we need to do it. This one is congruent to that one. And BD bisects angle ABC. Oh, wow, we haven't used that in a while. But remember, when you bisect an angle, it creates two equal parts. Remember, I had y'all say that all the time. Y'all always want to say that it cuts something in half, but we say that it creates two equal parts. So this is the angle that's being bisected. That's angle ABC. It's this top angle right here. And BD is bisecting it, so that means that this half is equal to that half. There's my two equal parts. I also have this shared side automatic in the middle. So which one would this one be? This would be side, angle, side. Side, angle, side. All right. Continue to finish this page. And if you're at home, you should be able to do these proofs over here now. And I'll probably do some of these in class, but I might go ahead and do this first one real quick right here. Well, no, probably going to run out of time on my timer. So look for me to post some pictures on this one. Good luck.